Good day, and welcome to our webinar, IIoT-based Analytics in the Enterprise, brought to you by CFE Media and Technology and sponsored by Donaldson Filtration Solutions, Epicor, Infor, and Oracle NetSuite. Joining us today will be Mohammed Abu Ali, founder and CEO, IoTco, and Isaac Bennett, Digital Transformation and IT Manager, Detroit Manufacturing Systems. I'm Kevin Parker, an editor with CFE Media and Technology. Today's presentation provides continuing education credits. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of this program will be reported to RECEP at recep.net. Manufacturers embracing digital transformation are leveraging analytics, machine learning, and artificial intelligence to achieve greater efficiency and productivity on shop floors and throughout the enterprise. Interactions between the real and virtual worlds in the form of models and digital twins can form the backbone of smart production systems founded on the principles of lean. The interconnection of things with the industrial Internet of Things-based technology can lead the way to a truly transparent manufacturing environment, a smart factory where use of analytics translates into enterprise success. A certificate of completion will be available for each participant to download upon successful completion of a test at the end of the presentation. As such, it does not include content that may be deemed or construed to be an approval or endorsement by RECEP. To take the Learning Unit exam, use the Learning Unit Exam tab option at the top of your screen. The exam will open in a separate browser window. You can complete the exam after the webcast. However, the link will break when the webcast signs off. Having trouble moving my slide. The exam will be posted on CFE Media websites with the on-demand version of this webcast. The exam is for one RECEP ASEC Certified Professional Development Hour. To get the best results from the webcast platform, please make note of the following. For technical problems, click on the question mark at the top right-hand corner of the screen to bring up a list of system checks to make before escalating to an online technician. If you experience issues with the slides or audio, please refresh the browser or click the Refresh Media button directly under the presenter's headshot. Volume settings can be controlled by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If a technician is needed, type a message into the Ask a Question box and someone will get to you as quickly as possible. Answers to technical questions will be found in the Answered Questions box on the left-hand side of the screen. The Ask a Question box is also used to ask the speakers questions. Ask questions at any time during the presentation. We'll get to as many as time allows. To download the presentation slides and certificate of completion, use the Event Resources box on the left-hand side of the screen. You can download the presentation and certificate of conclusion until the conclusion of the webcast. This webcast is being recorded, including the Q&A session. We'll send you an email message within a week with a direct link to the archive. We'll now hear from two sponsors of today's webinar, Donaldson and Infor. At the end of the videos, you may experience a few seconds of silence to compensate for varied internet speeds. Stay tuned for today's presentation and discussion. Welcome back. I'd now like to introduce our first speaker. Mo Abu Ali is the CEO and managing partner at IoTco, an Internet of Things company. As such, he is a strategic and transformative technology and business management leader with a 20-year record of achievement driving and sustaining change in manufacturing. Mo serves industrial and manufacturing clients in automotive, aerospace and defense, and other industries, providing digital transformation, industrial IIoT, and predictive analytics technology and services. Mo has a doctorate in industrial engineering. Mo, welcome to today's webinar, and please go ahead.
Thank you very much, Kevin, for the introduction. So this is Mo. Good afternoon. I'm pleased to be here with Isaac Bennett to give an introductory presentation on the industrial Internet of Things and the role of analytics shaping the digital transformation journey of manufacturing organizations. So I appreciate your time. If we look on a high level around IoT, the Internet of Things, we see two major domains of focus and specialization. One domain is obviously within the manufacturing facility, which will be the focus of today's presentation, how to use analytics to drive improvements on the factory floor. But another domain is actually in the products out in the field, sensorized products that are produced by manufacturers, and how we can use analytics to also drive further value from those products, okay? The analytics may be the same or they may be similar. However, obviously on the smart product side, there are differences. You should be able to see slide 9, so I'm okay moving through the slides. Then there are three practices that we bring to the market, and those three practices encompass the digital transformation journey of a client. One of those practices is, of course, the education side. I think the role of education is key in digital transformation. And once strategies are put in place, Industrial IoT would be able to go into manufacturing facilities and establish a data lake and bring in the needed information from assets and sensors and CNCs and machines, and then allow that data to be used for the purpose of predictive analytics. Okay, so we're gonna cover this in today's presentation and give you an introductory case study as well. So these are some of our clients. I think the message here is whether the manufacturer is large or small, size does not matter in this case. We have manufacturers like company here on the bottom right, 100-person organization, maybe a $50 million business, but yet connectivity and analytics have been a key to help them become a better tier 1 supplier or a small medium supplier to large organizations. Whereas you have larger companies who have multi-site operations, and there's here a need to scale up their analytics to monitor and benchmark, metrics like OEE and health of assets across multiple plants that are spanning multiple geographies, right? So size does not matter. It's actually about ROI, and it's about how to use data to drive improvement. So there's 4 things we're going to cover and touch on briefly today. I want to introduce industrial IoT and predictive analytics on a high level. I'll give some use cases around using analytics in the end. And my good friend Isaac Bennett will discuss their journey in their organization of how they were able to digitally transform or how they are digitally transforming today using analytics. So let's start. Some of you today may have heard about the 4th Industrial Revolution, maybe most of the people on the call. So in fact, the 4th Industrial Revolution, and this slide comes from the Fraunhofer Institute in Germany, the 4th Industrial Revolution is all about the digital connected world. Some refer to it as a cyber physical system, okay, CPS. Just imagine your manufacturing operations with your physical assets and your physical parts moving around, and how you can use the IT world and how you can use the internet to mirror and to model and to simulate your physical world in the cyber world. So the creation of these cyber physical systems allow manufacturers to collect data in real time and to simulate changes and to predict the future. Okay? So we've entered this age of the fourth industrial revolution. And in fact, this initiative was initially pushed by the German government many years ago and has now become a global initiative, under many names in many different countries. In the U.S., we sometimes refer to it as Manufacturing 4.0. Some companies have their own namings. General Electric refers to this as Brilliant Factory or Smart Factory. Okay, but let's start a little bit more from the top. So you have IoT. IoT is not a new field, actually. The Internet of Things have been around us for many years. Jet engines in the sky being monitored as they're moving from point A to point B. Many people on the call may have a Nest thermostat sitting at home where they're collecting data from the IoT device by Nest, and they're using it to, improve energy consumption in their manufacturing facility, right? But IoT has mostly been used in safety critical industries like aviation and nuclear power plant monitoring, where there is a necessity, and there has always been a necessity for safety. So now, taking some of those applications from other industries, there has been more and more application of IoT in the industrial or factory domain, and this is what we refer to as the Industrial Internet of Things. And Industry 4.0 is one of those initiatives that allow the realization of the Industrial Internet of Things across the spectrum. So if you look at a manufacturing facility, you typically have four layers. You have your machines, you have your data acquisition layer, which might exist in some cases it doesn't. You have your MES, your manufacturing execution systems that are running your plant. And you have ERP, your enterprise resource planning systems like SAP and Infor and Oracle, that are the business layers for finance and inventory and spare parts. The challenge here and the reason why IIoT exists is how can I marry those layers together? Because in many cases they are fragmented or they are siloed and there is no connectivity between those layers. So having an enterprise approach to collect data and to bridge the gap between those layers is essential in today's world. And how a manufacturer can start embarking on that journey is by starting to consider four key areas or four key pillars of a digital transformation strategy. And actually, we typically start from the right and we count backwards. 4, 3, 2, 1. 4 is your ROI. Why are you doing digital transformation, and where is the best place to start? We don't believe in big bang approaches to doing digital transformation in a complex environment. It most likely may fail. So think big, start small. Pick the right pocket of potential success and assess the business case. And by assessing your business case, go back and figure out, am I connected? Do I have a connected operation that allow me to collect the data to drive the business case? And once the connectivity is in place, what analytics do I need to start providing to my end users to drive the improvement? Am I looking to measure overall equipment effectiveness, OEE? Am I looking to measure machine health? Am I looking to predict a spindle bearing failure on my machine? So what are the relevant analytics for the end user that allows you to achieve that business case? And last but not least, once you start small and succeed fast and succeed with the proper metrics and the ROI, how can you scale that technology across the factory or across multiple factories? And what is the architecture of that scalability that goes with it? Okay. So these are some fundamentals of how IoT, IIoT, Industry 4.0, and the strategy that shapes these domains of experience. So let's start with the business case. Okay, you have your digital thread. Your digital thread starts when the raw material comes in and you design the part, and then the part is produced, and then the part is shipped, and then there's a user using that part somewhere out in the world, right? That's your digital thread. But if we look at two key areas, and I'll focus more on the left, smart factory, right? So if within the manufacturing environment of the digital thread, What is your business case? Are you improving uptime? You know, when I worked at Toyota 15 years ago, 1 minute of downtime in the Toyota facility was $10,000 for 1 minute of downtime because I'm not making cars. My line has stopped. No cars are being shipped out off the line, correct? So improving uptime and sustaining a high level of uptime allows you to boost your OEE numbers within the manufacturing facility. At the same time, spare parts systems are typically detached from the rest of the organizations. They are siloed. When a machine fails, a senior maintenance person goes to a system and inputs information manually. So how about a predictive analytics solution which can drive recommendations and drive predictions of when the machine is going to fail before it actually fails, and then request the relevant spare part to be automatically dispatched from your spare part system without the need for human intervention, because that could simply cause delays and miscommunication of information. So analytics can drive IT systems to do a better job, to optimize PM schedules, to optimize spare parts, and to improve and sustain your uptime and your OEE in the manufacturing facilities. And there comes what we call predictive quality. In some manufacturing environments, scrap rates are high, and by using analytics, not only can we predict machine issues, but we can predict scrap or defect issues on machines, okay? With the recent advances in technology and CNCs and automation and machine learning, we can actually start correlating machine data with process and quality data, which are typically coming off the machine or coming, off a quality measurement system of some sorts. And we can actually make precise predictions that your aluminum cast that you're going to make in your foundry is going to be a bad part before you even ship it to machining, or if it goes to a customer, you have a traceability problem, and that's the worst case scenario, right? So what is your business case? Is it uptime? Is it spare parts? Is it PM optimization? Is it scrap? Is it process optimization? Start with the business case, and the business case will drive your technology selection and deployment. And just a hint, if you are not a manufacturer and you make products, many new products today, like pumps and turbines and wind farms and gearboxes, they come sensorized, and that sensory data is going somewhere to the cloud potentially. So how can you apply analytics on that sensory data, the usage data of your parts, and offer more value-added applications to your customers? How can you servitize that data? How can you help them remote monitor and diagnose their equipment? Why would a customer call you and say, I want a new spare part? Why not call the customer and say, my system detected that you need a new spare part, and I've already shipped it to you to fix the machine before it actually fails, right? And last but not least, feeding data back to the design, actually. By collecting data within the factory and within the product itself in the field, using analytics, that data can actually be sent back to the design process to optimize future generations and future designs of that part. Okay, that data is valuable. They say data and analytics is actually the new oil, okay, in the manufacturing environment. And by harnessing that data in the best way, we can improve customer satisfaction and improve productivity within the manufacturing operation. I give you two quick case studies, one in a factory and one for a product. This is actually an ROI calculation from an automotive OEM who had 500 robotics. And as I mentioned, average cost of downtime was about $10,000 per minute. They had only 30 robots that actually failed every year. I mean, let's face it, robotics are made tough. They are not supposed to fail, but they do fail. And, their failure is on average 30 minutes, and that leads to $300,000 for a single robot failure. So if a predictive system can have a realistic ROI of only predicting 50% of those 30 failures of the 500 robotics, that factory can save and has saved I would say, very sufficient level of ROI just by making such assumptions. So the power of uptime improvement in a manufacturing facility that has uptime issues or where 1 minute of downtime is very costly, right? So think, what is your 1 minute of downtime, and how can you take actions to apply analytics to mitigate this downtime? And here's an example. Predictive systems should be user-friendly, okay? Maintenance people are not PhDs, they are not data scientists. They are looking for an intuitive way to look at the information and make decisions on the fly in a very competitive environment where things are moving fast. So by very easily seeing the health of your machine and seeing a prediction with an accuracy to failure, this is your remaining useful life. And by being able to diagnose here on the robotic that joint 5 or axis 5 on the robot has a failure prediction, action can be taken. And action can be taken to move away from a proactive maintenance or a reactive maintenance organization to a proactive and predictive maintenance organization. And that's the vision here. The vision is near zero downtime in a manufacturing facility. Okay. There comes another company who actually, they manufacture parts, but their issue is not in manufacturing. Their issue is, I'm sending these expensive excavators to the middle of the Australian desert to mine and to do their job, right? So they're running mining sites. But the issue is, engines and brake systems and all kinds of things on those excavators can fail. And when they do fail, spare parts are costly, and getting maintenance people out there to fix it is difficult because of the remote locations, right? So how can we apply analytics here in order to collect data, proper data, and actually send a spare part to fix the mining truck before it actually fails, okay? So imagine data loggers that are sitting in those vehicles, and those data loggers are crunching numbers that are coming out of the engine and the brake system and the alternator. And due to the remote location, there's no internet connection. So a satellite link opens up in the evenings typically, and the satellite link then is used to send predictive information. Edge analytics are happening here in the excavator, and the metadata like the machine health or the engine health, the engine prediction, the diagnosis is sent out once a day over satellite, and then giving a prediction of 2 to 4 week window at least to prepare and send spare parts and people to fix the excavators, right? So the use case here is different. The application is different. The end user is different. But guess what? The analytics are actually the same, The engine here can be an engine found in another car, can be an engine found in a manufacturing facility, or a gearbox found in a manufacturing facility, right? And this is a realization. Again, you have your mining site, you have 3 fleets. Those are the trucks within your fleet. And immediately, green, yellow, red. Green is healthy, yellow is degrading. You immediately can address the yellow issues here. This truck has a problem. And specifically, this truck has an issue with its diesel engine. And this information can be sent to the spare parts system of the organization to allow them to ensure that the mining site is running with 100% uptime, okay? So near zero downtime for the mining site using those expensive and remote excavator trucks. So bringing everything together, predictive analytics and enterprise analytics is all about creating a worry-free process for the end user, okay? We're all worried about machines failing, and so we need spare parts. We need to go fix them after they fail. We're all worried about making bad parts, so we try to put very stringent quality measurement approaches in the manufacturing organization. But in many cases, there's a lack of collecting the right data and analyzing it in the right fashion to deliver results that allow a worry-free process. A worry-free process is a zero downtime and a zero defect operation, okay? Any solution should allow you to bring in data. A high level of interoperability is very important, okay? Bring in data from the asset, from the process, bring in data from quality. This data might already be available in a data lake, or in some cases it's not available. So we have to instrument and we have to get data from new machines, legacy machines, maybe add sensors to the process. And then this allows you to create two use cases. One is predictive maintenance, which is focused on the machine, and second is predictive quality, which is focused on the part, okay? And it's all about using and synchronizing the right data that is related to the machine, the process, and the quality to deliver health and predictions and diagnosis relating to the machine and relating to the part. And it's very important to be able to address it in multiple manufacturing processes and apply this in multiple manufacturing types or environments, okay? So if you look at the critical assets in a manufacturing environment, in this case, it's an automotive organization. There's a lot of robotics. There is machining, including CNCs, injection molding, and so on. Stamping, ancillary equipment like pumps, motors, gearboxes. Within each one of those gray boxes is what we call a predictive solution template. Each solution template has a data model, and the data model allows you to collect data from sensors and controllers, and then allows you to run analytics and machine learning to create a baseline and then to deliver the predictive maintenance and the predictive quality use cases. Okay, let me show that to you briefly so you can picture that. Okay, once a data model is defined, for example, on a CNC machine, I have a spindle bearing. I'm collecting vibration data, I'm collecting current, I'm collecting temperature, voltage, and then that data is being transformed and prepared using a machine learning algorithm for signal processing. And then features are extracted. Those are statistics, time domain features, frequency domain features. Feature engineering is critical to reduce the dimensions of the signals into meaningful information. And then that information allows you to feed it into a machine learning health assessment model, and then that model tells you what is your machine health and what is your part health. And as the system evolves and it learns, it starts making predictions, and obviously predictions have accuracy, right? High levels and lower levels. Of course, the more data you collect, the accuracy will improve. And we strive to achieve a 95% confidence interval to the prediction as we collect more historical data. And then you have diagnosis, right? If I'm telling you Axis 5 on the robotic is going to fail in the next 2 weeks, what is the reason, right? Is it my temperature signal? Is it my pressure signal? Is it a backlash that's happening in the gearbox, right? Diagnosis takes a little bit longer in the predictive world. It is difficult to diagnose something that you don't have history of. You have not diagnosed in the past. So an enterprise analytics solution should be able to baseline and to create a fault library. So when faults occur, they save those faults, and in the future, we can then use that to actually predict future fault issues that are happening on the machine, right? So my message here is start with the business case. Have the business case drive the need for analytics, whether performance analytics like OEE or predictive analytics like machine health and predictions and quality issues. And then once you do that, apply it in a small scale and deliver the value, and then discuss scalability. And I think a great example to see that here is through Isaac Bennett's presentation, showing how they are architecting this today for DMS. So Isaac, pleasure to introduce you, and I'll hand it off to you, sir.
Well, thanks, Mo. This is Kevin. I'm going to turn to our second speaker and panelist, Isaac Bennett, as you've already mentioned. I just wanted to say that Isaac is Digital Transformation and IT Manager at Detroit Manufacturing Systems, and formerly the Global IT Innovation Manager at Maxion Wheels, both Tier 1 automotive suppliers. He has worked in the IT field for almost 20 years, leading automotive industry IT departments, including those engaged in global digital transformation initiatives, and in helping plants around the world implement smart manufacturing projects. Isaac, welcome to today's webinar, and please go ahead.
Thank you, Kevin, and thanks to Mo for setting me up here. And I always learn something new, and I've seen Mo present a couple times, so I always appreciate his presentations. And I'm glad Kevin mentioned, I think in the bio, I mentioned Maxion Wheels. because I'll refer to some of the stuff that I've done there, and I'm going to tell you my journey because I want to tell a story, and I think it's important. I think storytelling helps people remember things, and I think people can relate to it. So from a high level, currently I'm at Detroit Manufacturing Systems. They're a pretty young company, and Detroit Manufacturing Systems started from dirt. So they had a lot of struggles in the beginning, and I came in about 7 months ago to try to transform them into a more innovative company from an IT perspective, but also that translates to the plant floor as well. So they're a joint venture with Forcia. We have plants in Detroit and Toledo, and we mainly do component assembly. So you'll see our main customer in Detroit is Ford, and so you see a Ford cockpit there, and you see a Jeep cockpit for the Toledo facilities, and our main business is assembly, and that's what we do here at Detroit Manufacturing Systems. So I wanted to, like I said, tell you the story of how I got in where I am today, and how I experienced kind of the journey of Industry 4.0. As Mo said, there's a lot of different names that they give it: Industrial IoT, smart manufacturing. I spent a lot of time in my previous position in the plants, and as an IT manager, I managed the people in the facilities, the IT people in the plants. And as I managed those people, the one thing that I wanted to do as an IT person was build a relationship with the plant managers and controllers in those plants. I really wanted to understand their problems. The consistent message that was given to me was, we really need more IT help directly on the plant floor. And if anybody has been involved with smart manufacturing and Industry 4.0 concepts, the two worlds are colliding. The IT world is colliding with the operations technology, and you'll see people talk about IT and OT quite a bit. So coming back from managing plants in Europe with Maxeon Wheels, I had some strategic meetings with the organization and brought the message back to the IT organization, saying, hey, how can we as an IT organization partner with the business? And our CIO at the time said, hey, why don't you come up with a presentation? And this was over 4 years ago. So about 4.5 years ago, I put together a presentation, and that presentation really turned into a presentation about Industry 4.0 and where we are headed in the future with manufacturing. And so when we presented that presentation, it was probably, as my CIO had said at the time, had the most positive reaction from a presentation he had ever given. So from that, I grew into a position of digital transformation director at Maxeon Wheels, and that's where I started. So I think it's important to understand that message, because I think a lot of times people look at Industry 4.0 and they look at the concepts, and Industry 4.0 is a very, very big picture. Really, it's a big concept, and you can go into 3D printing or augmented reality and artificial intelligence and deep learning, and there's all kinds of different categories of Industry 4.0. So we knew this, and we wanted to say, okay, how are we going to tackle this? And as an IT person, yeah, I love technology, and I'd love to go out and buy all the bells and whistles and start plugging it in, but what makes sense was the question we started asking ourselves. I started on a more of an educational journey at first, teaching people what this meant, what Industry 4.0 meant. And it's interesting because people in the plants, generally, they're very busy people. They have their heads down and they have jobs to do. So generally, they're not looking up into the IT world and seeing what's out there. And so we quickly found, and I'm sure most people have found this if you're working in manufacturing, that the plants, depending where the plants are, at different maturity levels. So you got to kind of figure out where we're going to start. Some plants have MES systems, some don't have MES systems. Definitely, a lot of times departments are not collaborating much. So a lot of conversations about how Industry 4.0 is changing the way we work, because it is about connectivity, and it's not just about connecting sensors together or data together. It's about connecting problems and people together as well. So we noticed really quickly that there's a lot of stations that we noticed that data, sometimes you could collect data, but they had no reason to collect data. And sometimes the data was collected maybe just because of compliance, but the data was not being used for things, or they never saw any real value in collecting the data. So, and then of course, no standard solution. So you got 12, 15 different systems sometimes in a facility that in some way or other has data or can get data, but then you say, well, how do we put that data together? And I always make I always tell a little story, because I think people understand this way better, and I think a lot of people are bringing these smart devices into their homes. And Mo mentioned the Nest that you could have for controlling your heat, but I always tell a story of the reason why this is becoming easy to do in manufacturing is because how cheap those devices have become. And I used to bring a little sensor around with me. It was a $30 sensor that could do about 10 different things. And showing the people that sensor, those busy people in the plant, showing them that sensor kind of opens their minds and opens the door. And I always tell the story of how I have an Alexa device in my house, and then I have a smart plug that controls a fan downstairs in my basement. And nowadays I can just walk in and say, hey, Alexa, turn that fan on, and the fan turns on in my basement, and I don't have to walk down to the basement. And it's a very simple analogy, but if you expand that into a manufacturing facility, there's so much possibility with that. So why use data? I mean, that's always a question, and I think a lot of people are, with all the talk about data out there, and Mo also mentioned the idea of a data lake and gathering data in one central location. I think the maturity level depends on, you don't want to take up a big chunk and try to figure out how to put a data lake in. That's a big project, but just simple ways to start, and the simple ways that we've started is we're looking at just putting that data into a manufacturing intelligence system, and that's simply maybe just monitoring it, putting it into monitors, getting that data as much as we can, and putting into simple displays, putting simple reporting on it, things like that. When you start doing that, it's amazing the results that you will have from just displaying the data. But then there's also the next step of what can we do beyond that. And we talk about silos quite a bit, and if you think of it this way, and we had a lot of discussions about this in our production facilities, is if we start collecting data from those individual areas, how can we correlate that data through the process? There might be a process that's 3 or 4 stations down that we don't notice a quality issue until 3 or 4 stations down the line, but how can we correlate that data across the plant and start using that insight? And then we say, okay, well, we can see it, but then how can we further use that data and then maybe predict some things? And the important thing to mention here that I've mentioned to people before is, yeah, we have an idea of, yes, let's collect the data for one reason, but, and Mo mentioned this as well, is the predictive maintenance and the predictive quality. It's essentially the same data. So you start collecting that data, there is a multitude of things that you can do with that data in your plant to show good reasons for collecting that data. So, and I put this slide up there as an example, and I stole a picture from Mo's presentation, and I wanted to mention this because I don't want you to think it's a pie in the sky thing. This is happening in everyday facilities. And as I mentioned, the reason why it's becoming possible in the manufacturing environments is because of how inexpensive those sensors are today. 10 years ago, that probably wouldn't be the case. But being able to gather that data, especially from old machines, old legacy machines, is a big deal, especially for manufacturing facilities. You know, you have a big asset in your plant that you don't want to replace, but also you're thinking, well, how am I going to collect data from this old thing? And you would be surprised how easy and simple it is to censor up some of those old devices and start collecting data from those devices. And once you start collecting simple data from those devices, and I've heard stories of just simply collecting the sound that's happening around those devices could be an effective thing to start looking at, you know, the sound or vibration is changing on the particular machine. You know, there used to be those guys that would walk around the plant, and there still is some of those guys that would walk around the plant, and just by unfortunately, those people are disappearing. So beyond the fact that we can tell what's going on with the machine, we're able to start putting those into some AI and machine learning, and we're able to train the model, and then we're able to prove and show that we can predict when a machine is actually going to break down, which is pretty exciting. So I wanted to put this slide in there, and I think you heard Mo say this as well. This is really important for us as a company. That and I've actually talked to some experts in the industry, and it's a reason why we started with this type of format. And it's the think big, start small. So starting small, but having the bigger picture and the bigger strategy in place. So that you can scale fast. And people hate to hear me say this, but you know, the fail is a bad word, but I think it's having an organization that accepts failure. So if you start with something small, you can, of course, if it fails, you fail small. But if you have the big strategy in mind and you're able to think about it strategically with the big picture in mind, you're then also thinking about how you can scale this quickly. It's important to look for solutions like that. And that was very important when we were looking for solutions like this, is how can we scale this quickly? How can we start with a small project? And it was very, very interesting is I also didn't want to just have corporate IT drop in a plant and throw sensors on machines. So we conducted these workshops. You can see how we did the workshops, and we wanted the plant to be part of the process. And I'm just the IT guy, and that's what I would tell them. I'm the IT guy. I don't understand the production floor as well as you do. So, you know, having that partnership and sitting down in a workshop and talking about the details of what is their actual problem. I want to know what your problems are on a daily basis. We can discuss those. We can talk about if that is a good area to tackle. And if we find a good low-hanging fruit, as you hear people say quite a bit, that could have a good ROI, a good return on investment, and it's a simple project, and you think that it could be very scalable throughout your business, that's what our wanting to do in these workshops is to make sure that we vet out that stuff and not just start throwing technology at plants. So again, to emphasize, building a business case is hugely important. Being able to sell this across the business and having the big picture in mind. And right now at Detroit Manufacturing Systems, we are looking to collect that data as quickly as possible so that we can gain value. We have tons of dashboarding right now across the plant. I can tell you that. We have dashboards everywhere. But the problem is, yeah, we have the dashboards, but how do we get that data together into one system? We're looking at all kinds of MES replacements that are modern MES systems that are in the cloud, that are doing edge analytics, so they can do the analytics on the plant floor. before you send your data to the cloud for reporting and dashboarding. We're looking at collecting data from our injection molding systems so that we can do reporting and have visibility on that. But also, we're looking really closely at doing predictive maintenance and predictive quality on those injection molding machines. And I can tell you I've done it before, and my story is that this is not just talk. This is possible. So as you're looking at this journey, again, I can't emphasize enough to think about some small pilot projects you can deploy quickly and efficiently. And if you have success, then you can go across your plants and show some real value to your business. So that's it from me. I think I'm going to hand it back to Kevin.
Well, thanks, Isaac. Before we turn to the Q&A session, let's hear from our second set of webinar sponsors, Oracle, NetSuite, and Epicor.
Between all of our different product lines, we have close to 1,000 items and several thousand kits. It was just too big to manage.
We could not do it without the right technology partner, and it became NetSuite.
Using NetSuite and having Suite Commerce allows us to manage multiple areas, multiple facets. It's connected to your ERP and to your website.
To manage transactions, to search transactions, to really see what was going on in the business, you have just mass amounts of data at your fingertips.
Many mid-market manufacturers recognize that Industry 4.0 will impact their manufacturing operations sometime in the future. But today, many still aren't sure exactly how or when this will occur. The good news is, manufacturers are already well prepared for this, as machines on the shop floor already include sensors that provide real-time data to floor managers and the operations team on performance levels. But how do you make sense of all this data? For starters, a manufacturer's ERP system must have the ability to collect, filter, and analyze data at critical points in the manufacturing process so that users can make better decisions based on insights from real data. This is why it's crucial to select an ERP solution capable of leveraging new technologies to bring information to those who need it, when they need it, and in a way that they can act upon immediately, anywhere. With these capabilities, the value to business comes from increasing the reach of ERP to every part of an organization, making it as usable on the shop floor as it is in the boardroom. The future may not be here, but it's coming, and manufacturers should move now to ensure their ERP platform is future-ready to adjust Industry 4.0 demands and support the industrial Internet of Things.
Well, welcome back, everyone. We've got about 10 minutes to handle some Q&A, so please send us your questions now. Mo and Isaac, we here at CFE Media and Technology have recently done quite a bit of surveying about the topic of edge computing or IIoT, and one thing that we saw was that about 90% of the audience or respondents thought that there was further training or additional skills that their enterprise needed to really become conversant with edge computing or IIoT. Mo, is that your impression as well, that most enterprises need enhanced skills, and what skills do you see them most often in being in need of?
Yeah, I think that's a good question, Kevin. So I think there are existing skill sets in a manufacturing operation, folks who are more in the manufacturing IT sector, who understand ERP and MES and the different areas of a plant. And I think some of those folks, could be geared towards reskilling or learning a little bit more on new IIoT initiatives. But I think there are existing skill sets. I think where the lack might be is more on the data science and the machine learning and the AI side of things. And this is where I'm seeing more and more companies engage with universities and academic settings and try to bring in interns who have that statistical, mathematical background or knowledge, or those who don't, typically end up going to third parties and outsourcing that skill set. But I do see a great need for companies to start, investing in future generations of data scientists and statisticians who may complement their existing resources for the future.
Great, Mo. Isaac, what's your take on that challenge? Do you need data engineers, or do you have the domain experts who can become conversant with the technology, who can deal with these kinds of engagements?
I think it's an interesting question, and for me, and I've said this a lot, is it's a lot of a culture shift, and I mentioned it in my presentation about IT and OT technology, that they're two converging worlds, and I think there is a lot of people in the plant, in the innovation kind of side of things. There's the idea of leveraging your resources. So I think the idea is look and see what your skill sets are. You may have some people in there already working in IT who really are working as a database administrator who love data, but they don't understand the plant floor. So I think those two worlds, as they collide, the collaboration between the OT side and the IT side is going to become more and more important. In fact, I've heard of companies making departments out of it, calling it manufacturing technology, kind of converging their IT and OT. So I think there's some really smart people that we can use on our plant floors that are not being used as much as we should be using them, and then vice versa. There's some IT people and converging those both worlds. But as Mo said, I think the data side of understanding machine learning and artificial intelligence is probably the one spot where most companies don't really have anyone. And one of the projects I did in my last company it was very interesting. We brought in a company to sit down across from the manufacturing people, and those people who understand AI also don't understand production. So those conversations across the table between the production guys and the machine learning data guys is very interesting as well. So I think there is a gap there, but I think it's not that hard to bridge that gap.
Yeah, it's like you're moving from an IT-OT schism to a domain expert data scientist schism. Let me ask you another question, Isaac. Another challenge that we hear about when it comes to IIoT projects is that companies can kind of tend to get stuck in pilot purgatory, if you will. How have you handled that transition from small projects, pilots, and so forth, to something that's a little bit more scaled?
Yeah, I'm a big proponent as an IT guy. I'm a big proponent of using the latest IT technology. And, you can get into that, and I've heard the story many times, you can get into that mode of we're going to build this ourselves. We're going to set up our own, data science office, and we're going to try to do this ourselves. And I'm very much a proponent of, and there's a trend in IT with software companies of opening up their back end. So if you heard of REST APIs and being able to connect their system into your system. So manufacturing companies in general, they're lean companies. They can't afford always to bring a big infrastructure in. And if they do that, sometimes you get stuck. So I think leaning on some of the cloud technologies, some of the new software out there that is running on web-based applications that have open APIs that can connect into to other systems easily, that together with using kind of a software as a service model, so you can jump into a a company that's doing this with a monthly subscription, but then, hey, you can jump right back out if it's not working well. That for me is one of the biggest strategies. But then, of course, you have to have business buy-in. So having business buy-in is if not more important.
Good. Thanks, Isaac. Mo, another point of discussion when it comes to IIoT projects is to what extent it's a technology that is being applied primarily in greenfield environments as opposed to retrofitting it as a brownfield exercise. Do you think people are getting more comfortable with the idea of cost-effectively applying IIoT in installed systems?
Yeah, that's a very valid question. I mean, obviously, in greenfield scenarios, when you're constructing plants, there's much more control, and it's much easier to architect it in a way where data becomes available, automation is there to help you, and we've seen greenfield sites that actually go live and they start making parts, and the IT systems and the automation are fully ready. So they're kind of built to be smart, I would say. But when it comes to brownfield sites, I mean, obviously, those are older plants. Some of them have legacy equipment, and it becomes a much more complex task. And many of them come with, in this case, it's not pilot purgatory. It's more of existing system purgatory. I mean, they have systems that are deeply entrenched into their operations, very mission-critical systems, and even though those systems might be costing them too much, they have a difficult time pulling a plug and moving on to another system, which may give them a better ROI. So I think there's a different business case there. I think an assessment needs to be done to understand, where they are, what is their maturity, which systems are they using that are more critical than others, and working out a transition plan where some systems may be ripped and replaced, whereas other systems may be complemented and leveraged to improve their performance using IIoT. So we deal a lot with brownfield sites and how to assess and improve their maturity. It is a complex task.
Good. Thanks, Mo. Isaac, the final question for today is going to come to you, and that's another challenge that we hear in relationship to IIoT. You talked about companies that had data but didn't use it, and then you talked about companies that maybe gathered the data and monitored it but didn't analyze it. When you, in the numerous case studies that you've been involved in, have you encountered the fact that when you do get the data together, it's not sufficiently normalized so that it can be analyzed in context, or doesn't have so many outliers that it kind of spoils the mix? What has been your experience when it comes to making the data that's gathered fit for use?
Yeah, I mean, you hear the adage, garbage in, garbage out. So that's definitely a concern. And I mean, I've been in cases where in some particular MES systems where they have downtime, but they're only gathering like 30% of the downtime. So, I mean, in that case, some data is useful as long as it's accurate. But as you said, I think that's the conversations that have to happen on a plant level, not assuming that the data is all good, but sitting together in a room and having one of those workshops and discussing that. Because the one thing that I emphasize all the time, and people will laugh about this, but sometimes there's a quality report that is sent to corporate, and sometimes there's a real quality report. So you have to, I think you really need to sit down with the plant floor and really get shoulder to shoulder with those people and understand the data before you start doing this type of thing. Because, as I said at the beginning, garbage in, garbage out, it won't work. Yeah.
Good, great. Well, thanks to both of you for joining us today and sharing your insights. That's all the questions we have time for today. Besides thanking our speakers, we'd like to thank all those who were in attendance. We hope it suited your purposes. For more information, go to the website link noted in the interface. I'd like to thank our sponsors for today's webcast, and now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as this webcast ends. Please take a moment to complete it as we use this information to improve our webcasts. Again, on behalf of CFE Media and Technology, we'll see you next time.
Thank you, Kevin. Thank you, Isaac.
Thanks, Bill.